Hi everyone, we are from Group 3 and my group will present group project assignment for course BEJ10303 Electric Circuit 1. We have 3 group members. My name is Luis Tang and my group members is Nogan Yangadra and Abdul Sadiq. Next, I will pass my turn to Abdul Sadiq to explain about task 1.
Thank you, Luis. My name is Abdul Sabik and I will present about introduction. So the aim of this group project is to know how to solve the question that is given by implementing all the familiar and what we already learned in course electric circuit 1 that is suitable to get the answer for the problem. So the objective of this project is to know how to use nodal and mesh analysis and to know how to construct circuit using Proteus software and to know how source transformation work. So this is task 1. Students are required to do a calculation using nodal analysis calculation and mesh analysis for the circuit given in figure 1. For the analysis, students are required to find all net voltage for the circuit, and for mesh analysis, students are required to find all mesh current for the circuit. So this is solution 1. Solution for task 1, which is nodal analysis. So there is two nodes, which is node A and node B. So in order to solve this question, we need to use KCL, which is Kirchhoff current law, and we will got 13 V1 minus 7 V2 equal to 8. And for node B, we do the same thing as we do at node A, and we will get 11 V2 minus 7 V1 equal to 64. After that, after we got both of the equation, to get the value of V1 and V2, we use Cramer's rule. After that, we know that V1 equal to 5.7 volt and V2 equal to 9.4 volt. Next is mesh analysis. So as you can see, there is 4 mesh current loop. So for loop 1, I1 equals to 2 ampere, and loop 2, we need to use KCL, which is Kirchhoff voltage law, to get the equation of 9I2 minus 2I1 minus 4I4 minus 3I3 equal to 0. So for loop 3, the value is negative 4 ampere because the direction of 4A and the mesh rotation for I3 is not the same. So for loop 4, we do the same thing as loop 2 and we will get 7I4 minus 4I2 equal to 4. And then we insert equation loop 3 and loop 2 in equation loop 1. After that, after we substitute the value of loop 3 and loop 2, we will get 9I2 minus 4I4 equal to negative 8. So we use Cramer's rule and we will get the value of I1, I2, I3, and I4, which is I1 equal to 2A, I2 equal to negative 0.9A, I3 equal to negative 4A, and I4 equal to 0.0845 ampere. That's all for me. I will pass to Luis for task 2.
Now, I explain about task 2. Task 2 is students are required to conduct an experiment by using any computer simulation tools available, for example, OCAD, BSPICE, multi-sim electronic workbench, or Proteus design suite to prove the result in task 1. So our group choose Proteus design to draw the circuit. This one is the circuit for task 1. We need to draw in the Proteus. This one is the circuits that we draw in the Proteus. R1, R2, R3, R4, R5, R6 are resistor. And I1 and I2 is the current source and V1 is battery. So now we need to calculate the V1 and V2. So we need to put the DC voltmeter as V1 here and DC voltmeter and V2 here. In Proteus, we get the 5.7 watt for V1 and 9.45 watt for V2. In manual calculation, V1 will get the 5.7 watt and V2 is 9.4 watt. It's not much different. Next, we will be going to the mesh analysis. So we need to see the loop 1, loop 2, loop 3, and loop 4. What is the current there? For I1 is 2 ampere and I2 is negative 0.85, I3 is negative 4, and I4 is 0.08. For manual calculation, it's not fast different. So that's all for me, and I will pass my turn to Dania Najwa to explain about the task 3. Thank you.
My name is Dania and I will explain about task number 3. Consider the circuit in figure 2. Find VO by simplifying the circuit using source transformation. So given I equal to 2.5 ampere. So the step number 1 is combine the 6 and 3 ohm. So 6 times 3 over 6 plus 3 equal to 2, and then 2 plus 10 ohm equal to 12 ohm. And then step number 2 is using source transformation for both current source to voltage source. And then V equal to IR. So 2 ampere times 16 equal to 32 volt, and 3 ampere times 12 equal to 36 volt. So the step number 3, simply the circuit by 18 voltage source and series resistor. So step number 4 is use source transformation for voltage source to current source. So I equal to V over R. So 24 volt over 36 equal to 2 over 3 ampere. And then step number 5 is combine 36 and 12 in parallel. So we get the 9 ohm, and then step number 6 is use source transformation for current source to voltage source. So V equal to IR, 2 over 3 times 9 equal to 6 volt. And then step number 7 is we need to apply KVL. So negative 42 volt plus 28 and minus VO equal to 0. So negative 42 plus 28 and replace the I with the 2.5 ampere equal to VO. So we get the VO equal to 28 volt. So I will pass my turn to Luis to explain about discussion.
Analysis and discussion. We are able to study method of nodal analysis and mesh analysis for task 1, circuit design for task 2, and source transformation, KVL, Kirchhoff voltage law for task 3. For task 1, we are able to apply the method nodal analysis and mesh analysis to do the calculation for the circuit of figure 1 in task 1. Task 2, Broca's design simulator was used to set up the simulation circuit of figure 1. We will use the software to prove the result that we find in task 1. Task 1 node voltage shows V1 equal to 5.7 volt and V2 is 9.45 volt. In Broca's using DC voltmeter to prove the result. The mesh current loop 1, 2, 3, and 4. The 1 is get 2 ampere, loop 2 is negative 0.85, loop 3 is negative 4, and loop 4 is 0.08 ampere. In Broca's using DC ammeter to prove the result. For task 3, we are able to apply source transformation in circuit task 3. We need to find the VO in the circuit. The current of the circuit is provided I equal to 2.5 ampere. In the circuit, we need to simplify the circuit using source transformation into single mesh and write in KVL equation. Now is passed to Daniel Najwa to conclude the project.
In conclusion, we have learned and be able to understand the knowledge of electric circuits. We also learned about how to analyze the circuit. Then we are able to give comprehensive understanding of electric circuit fundamentals like mesh analysis, voltage divider rules, and nodal analysis. We also learned and be able to run the circuit by using Proteus simulation software. Lastly, we are able to apply the knowledge that we learned in the group project assignment. That's all from our group. Thank you, everyone.